Welcome to the fastest way to learn data structures and algorithms. Today, we are mastering LeetCode 104. Maximum depth of binary tree. This is a foundational problem for understanding recursion and tree traversals. Let's look at the problem statement. We are given the root of a binary tree and need to find its maximum depth. The depth is defined as the number of nodes along the longest path from the root down to the farthest leaf. Think of it like measuring the height of a building, floor by floor. To know the total height, you look at each wing of the building, find which one has more floors, and add one for the ground floor you're standing on. It's that simple. For our strategy, we'll use recursion. The depth of any node is simply 1, plus the maximum depth of its left and right children. If we reach a null node, we know its depth is 0. This bottom-up approach ensures we calculate every path accurately. Let's dive into the dry run. Look at the tree on the screen. We start at the root, node 3. To find the depth of node 3, we first ask for the depth of its left child, node 9. Node 9 is a leaf. Its children are null, so they return 0. Node 9 adds 1 and returns a depth of 1 to the root. Now, we look at node 3's right child, node 20. Node 20 asks its children. Node 15 is a leaf, it returns 1. Node 7 is also a leaf, it returns 1. Node 20 takes the maximum of 1 and 1. Adds 1 for itself, and returns 2 to the root. Finally, back at node 3. It takes the maximum of its left child's depth. 1, and its right child's depth. 2, the max is 2. We add 1 for the root itself, giving us a final maximum depth of 3. Now, let's look at the Python code. We define a recursive function maxDepth. First, the base case, if the root is null, we return 0. Otherwise, we recursively call maxDepth on the left and right children. We take the maximum of these two results and add 1. This elegant solution captures the tree's depth in just a few lines of code. Looking at the complexity, the time complexity is O of n, where n is the number of nodes, because we must visit every node exactly once. The space complexity is O of h, where h is the height of the tree, representing the maximum depth of the recursive call stack. And that is LeetCode 104 mastered. Save this video for your next interview and follow Leo Academy for more premium DSA guides.